Let's now make a more rigorous definition of what we just did in the Mozart system. So we created a variable in memory. We created an identifier which was somehow linked to this variable. So here the identifier x is linked to the result of this calculation. So in fact the declare instruction here does three things. It declares or creates a variable in memory which is then designated by x. And then when we do the equality here, it assigns to the variable in memory the value 7,006,652, the result of the calculation. And finally, it calls the procedure browse with the argument x. And this opens the browser window. So let's show now what's really going on here in terms of programming concepts. So we have here on the left the program text and on the right the system memory. So the x here, I've done it in red, is an identifier. So this is the concept that we see. It's a character sequence starting with a capital letter. So for example, var with a capital V, A, X123, First Capital Bank, or some examples. But this is just a one character, X. And then the second concept is one we do not see, which is the variable in memory. I will always denote these by small italic letters. So the little x here is a variable in memory. It starts out being unbound, but it will be bound to a value. So variables in memory here are in fact shortcuts for values. We will bind them to values. They can only be assigned to one value, so they're like mathematical variables. This is in fact a consequence of being in the functional paradigm, and we cannot assign multiply. So multiple assignment is another concept we will see later in the course, but does not exist in the functional paradigm. Final point is the type of the variable. So this variable will be bound to an integer, and in fact one can bind a variable to many different kinds of things, different types, and it's only known at runtime. So this is an approach called dynamic typing. So we have then a third concept here, the link between the identifier and the variable in memory. This link, which I call E here, is called an environment. So the declare instruction will create a new variable in memory, but will also link them. So it sets up this environment. So the environment is in fact a function. And I will write this function like this. So it's a set of pairs. Here we have one pair, which is identifier x going to variable little x, but there could be more, and we will see more in later examples. So it's in fact a function that takes the identifier, here x, and returns a variable. E of identifier x is equal to little x. So this environment will link the identifiers and their corresponding values. And now, in later examples, we'll see how programs calculate with environments, how different environments are calculated, because that's key to controlling the calculation that a program does.